right, our third and final video explaining how do you balance these redox reactions in acidic solutions. So hopefully you thought about this one like I asked you, and I think your thinking hopefully was probably along this line. We talked about tin in the second lecture. We talked about the chloride ion, and we talked about permanganate. So that's what makes this a challenging problem. You know the rule for tin. That could go from +2 to +4. That's up. That's oxidation. The chloride go from -1 to 0. That's up. That's oxidation. And we had a nice reduction reaction for permanganate. So the permanganate's kind of settled. That's going to be one of the reactants, and that's going to be one of the reactants. Again, how did you know that? You just did. You just knew. You either looked it up or you committed those to memory. Next week, you're going to have them memorized for the quiz that we take on this. All right. So now, the chloride ion, certainly in theory, could do this. That's an oxidation reaction. But here is the key thing that hopefully you realized, that when the chlorine is kind of deciding between the two, the metal will be oxidized. All right? And it'll go from Sn +2 to Sn +4. So that is the case there. So hopefully you pulled it up to that slide and you realize that, yep, that's what's going to happen. So this is, these are your two starting points. There's your two products, and we need to balance this using 1, 2, 3, 4, 5, 6, 7. And you're going to show all the steps. You're going to go reduction 1 through 5, oxidation 1 through 5, and then 6 and 7 for the whole reaction. It is important to note here that these problems, it will specify that it is acidic or it's an acidified reaction. Like next week, and we'll stop today when we get to basic reactions, we'll stop there. There's just sort of a little extra step that you need to add, but the other things are pretty much the same. Okay, so let's go ahead and let's start with the reduction half reaction. So this is the overall unbalanced reaction. That's just not complete. And you can see here that for the reduction reaction, that's going to be the one with the permanganate, the MnO4 going to Mn+2. And if you remember, step 2 was balance the magnesiums, which is or the manganese atoms, which is already done. And there's one on each side. But again, you'll rewrite it as a communication that you understand. That is what was being done in this step. Now we're going to go through these fairly quickly. We're going to go through these steps. So if you need to hit the pause, go ahead and do it, because you got a lot of stuff to write down. And then we're going to use the water molecules to balance the oxygens, because there are no oxygens on that side. And you're going to have to then go back and fix the hydrogens. Okay? So make sure you get that all caught up and hit the pause, because this next step, understanding this next step, is one of the keys to getting these problems down. Okay, so hopefully you got that all written and you're ready to roll here. And you can see that there is a minus charge on this side. There are 8 pluses. That's a net of +7 on this side and +2 on that side. Well, those charges don't balance. So what you balance them with is electrons. Now this is reduction, so you know the electrons are going to go on this side. So if you have that 7, if you add 5 electrons to that, that would leave +2, and then +2 equals +2. All will be right in the world. So think that one through. Make sure that you're understanding that these 5 minuses, along with that one, that's 6 minuses, 8 pluses, that's a net of +2. And that's what it is on the right side. And that's why you needed 5 electrons. And that number is crucial to getting this thing balanced. Now that you figured out it was in fact the tin that you're doing and not the chloride ion, this step becomes one of those, just a little bit of busy work here, but I'm going to hold you to this on the quiz and these problems that you will be practicing tomorrow. Again, just good notes today. That's all we need. So right there, boom and boom, because the tin is balanced. And then you got to balance the oxygen, ain't no oxygen. You got to balance the hydrogen, ain't no hydrogen. So those steps are very straightforward. So how do you balance these charges? Well, remember, this is oxidation. That's LEO, or losing electrons. So the electrons are on the product side, to lose, to puke them out on that side there. That's how those electrons come out. So there's your 2 electrons right there. That now balances the charges, as you can see. The 2 minuses and the 4 pluses leave a net of +2, and that's what's on the left side. All right? So when doing your problems, you will stop and you will say step 6, and you'll say this is my reduction reaction, this is my oxidation reaction. You will put square brackets around the outside, and you will multiply them by the appropriate number. Well, here we have a 5 and a 2. The least common multiple between those, of course, is 10. So that means you just sort of crisscross applesauce, multiply the 5 by 2 and the 2 by 5. And remember, that 2 needs to carry through on everything. So that is going to complicate this quite a bit. And you can see those coefficients technically can be reduced. You just doubled them all. But you got to leave it in that form, because we have to, the reduction, you have to gain 10 electrons and you have to lose 10 electrons. So there's what we're going to do with the tin reaction. Now you will stack them and do a step 7. Do not combine steps 6 and 7. So rewrite that using the correct coefficients, and rewrite that one using the correct coefficients. The electrons will cancel out. There are no other like terms on both sides, so your very complex balanced equation for that original thing, what happens when you put permanganate in this tin chloride? Well, this is what happens, and that's the balanced chemical equation. So that is a nifty little thing. And they haven't put one of these on the AP exam in a little while, so I'm kind of thinking they're due for one of these that you can show how you have this process down. Okay? So, there's one other case that you'll run into. If you were working with something that already has hydrogen and oxygen, it's just a little bit different, and this is the one. So there's your overall reaction. That's what happens to hydrogen peroxide. You can add a catalyst, and you might remember the foaming toothpaste and the big tube that we did. So you get oxygen gas and water. But now, what do I write? And in this one, we're just gonna do the half reaction for the equation here. Okay, write the balanced oxidation half reaction. Okay, so we're just going to do the oxidation portion of that. Well, hopefully you remember again that we had some rules back here. So you're going to go back and you go, oh yeah, hydrogen peroxide. That is the oxidation. Now, the rare case where it's -1 and it goes up to 0, that's oxidation. So that's how you are wise in the ways of AP chemistry, and you don't write the whole reaction, you write the half reaction. And then you're like, well, balance everything that isn't a hydrogen or an oxygen. Well, that's done already, because that's the only element that's in there. Balance the oxygen, done. And now how do you balance the hydrogen? Well, you just do that because it's in an acidic solution. You can put the 2 H pluses on that side. Okay, now you'll notice we're heavy on the pluses. It's an oxidation reaction, so the electrons are going to go over there, and it's pretty easy to see on this one that that is 2 electrons. Okay? Look these over again. Work day tomorrow to practice some of these in class. Don't start the assignment because there's a formatting that I want you to follow for this. And I will let you know that tomorrow. You can see the next thing we're doing is what happens if it's in a basic solution. And that's something that we'll add on Monday. Okay? All right. So you still probably have your other homework assignment to submit. Your Wednesday homework, remember, was due on Friday. But nothing new today in terms of coming up with new assignments. And I apologize for not posting the key for Wednesday's assignment right away, but I did get that posted, so that's on there now on Wednesday's assignment for the first part of 4.9 lecture. Okay, and that's it. Take care, everyone. Bye-bye from Chammy.